Thank you to our sponsors for today's video, Amber, StarCharge, Eaton, and InfyPower. Today's video is sponsored by Amber, providing modern protection plans for your Tesla's battery and more, without the hassle of long-term contracts or upfront payments. Check out the link in the description to explore their plan options and use code SPEC5 for a 5% discount on all plans. This video is also brought to you by StarCharge, the largest EV charging manufacturer in the world, and is also a provider of residential and commercial battery storage with microgrid solutions. And Eaton. Eaton is a one-stop shop for implementing reliable and innovative EV charging infrastructure at your site. Across all applications, Eaton's EV charging infrastructure, hardware, and software gives you the scalability, flexibility, and intelligence you need to charge today and scale up tomorrow. Learn more at eaton.com/EVCI. And InfyPower, the largest EV charger module provider with over 3 million power modules running reliably worldwide. Their latest G2 collection features ultra-high power density and efficiency for EV charging and energy storage integration. InfyPower, innovation for your power.
Hello and welcome to another Out of Spec Reviews video. Welcome here to our office in Northern Colorado, and welcome to update video 2 of our XCharge Net Zero series, our own DC fast charger with battery integration. This right here is a 233 kilowatt hour battery pack, LFP battery, which is almost the same size as the battery pack that's in this Silverado EV. And well, in a previous episode, I walked you through the entire installation process, turning it on for the first time, and this is really where I'm going to show you how the heck the thing works, how it charges under the ultimate stress test conditions. Now, of course, it's also been installed here at our office for a few weeks now, and I'm going to give you all of the statistics and everything like that in an upcoming video, which will really be like a review of the unit. But today it's all about stress testing it. So we'll be giving it a really tough time getting it to charge one of the lowest voltage new vehicles on sale. We'll be then having it charge one of the highest voltage vehicles on sale, Lucid Air Grand Touring, up to 924 volts, I believe, up to 100% state of charge. Both are extremely hard on the power modules. And then we will give it the ultimate stress test of charging a Silverado EV from 0 to 100% in one charging session, and just see what the heck happens. I'll explain some more about what we're gonna do. I'll walk you through the charger, and then we are gonna just absolutely beat the crap out of it in this video. Guys, well, come on over. This is our XCharge Net Zero series. And in the previous episode, we walked through installing it and a little bit about how it worked, but just as a refresher, come around back with me. This is a really unique charging station, charging situation, because it doesn't have a high power grid connection. It was really the only type of charger we could have installed by replacing a level 2 station. We had a conduit, a very small conduit running into our building. If you look behind you, our office building right here, CSU's powerhouse. And with that, you know, if we wanted to put a high power DC charger in, we really could have. The building has the power to run them, and we are installing them in the back, but we would have had to bore under the whole building and through the parking lot. The idea with our XCharge Net Zero series was to have a small grid connection that we could upgrade to a 480 3-phase connection point to get the most out of that conduit fill. And then basically slow charge a battery pack, which will then feed as the buffer to output high power charging into a vehicle. And that's exactly what we have going. We have a 480 volt 3-phase connection coming out of the ground. So a lot of you commented, well, I should say a couple of you commented, and I totally agree. We did the calculations wrong on how much power we could actually pull out of the ground. I think we had it set to 19 kilowatts when really, to do a 3-phase connection, I was doing the math wrong. We should have done like a 30 or 32 kilowatt connection from the grid. So I bumped this up to a 30 kilowatt feed now from our connection. For the last couple weeks, I've had it at 30 kilowatts, no issues, all good. And we're still well under our 80% maximum capacity for continuous load. So thank you to those who commented that I was calculating it based off of a single split phase rather than a 3-phase connection, the 480 3-phase connection. So we're good. So we have 30 kilowatts plus going into this battery pack now, which is awesome. And what's kind of cool is you can see here, this is our main breaker disconnect, which, you know, we have had no reason to shut off at any point so far. That goes into our dispenser unit. Inside this dispenser unit does all of the control between the battery and the output and everything like that. There's also a transformer here, which is only on the older versions of XCharge NZS. The new ones won't have a transformer. They're battery integrated ones, but this is to run basically all the HVAC systems for the battery pack. The heating and the cooling operate on a different electrical voltage and then our grid connection. So that's why we have just a little tiny transformer, but in a nice looking box. The install location, okay, it's not my favorite. I don't really know. I wasn't here like when it was all installed. There were reasons to try and cram it into one parking space. And there's also, you know, sort of sizing requirements on the space you need to open doors and stuff. But I really wish this was just mounted back. However, coming back over here, I'll show you in a bit, we can easily fit the Silverado EV in this parking space without going over anything whatsoever. So on the dispenser side, you can see this size said unavailable at the moment. I actually just disabled it through software, so no one rolled up and used the charger. That's the nice thing about having your own charger. We try to provide charging to, you know, Powerhouse employees and colleagues of ours when they're here, but when I need to use it for testing, boom, this thing goes off and I get it to myself. And that is just a great feeling. I love having high power, dedicated charging just to our own needs here at the office. It's awesome. And so that's what I've done here. I wanted to make sure that this battery charged to 100% for our Silverado testing. So I shut this unit off last night and it, you know, gets a lot of use. So it got up to 100%, no problem. We'll talk through a lot more of that. And I've just turned on the CCS side here with the Equinox. So I have CCS on the left and NACS on the right, J3400 on the right. The cable management on this unit, I think that's maybe its only and main weakness. Of course, the size needs to be big because we have 233 kilowatt hours. I want to say usable is 208, 209, somewhere around there, usable out of that. And they're LFP cells made by BYD, which is pretty cool. So it's still showing 100% state of health and full capacity, which is wonderful. The unit is really getting a ton of usage out of it. I mean, megawatt hours. I think we're averaging about 1.5 to 2 megawatt hours of dispensing energy every week, which is awesome to see. You can see right here, just since the last reset, we've done about 7 megawatt hours in and out of the battery pack. You know, there's always some losses, so 6.7 in, 6.1 out. But that, of course, will adjust over time, and I can pull up the full data for everyone as we go. So with that said, now is time for the stress test. I want to see, can this charger do things that chargers need to do, which is charge cars at the extremes. Many of you know that we've had a really hard time, especially before our Lucid range tests, getting it to charge to 100%. And it is sort of an anomaly just how high voltage that car gets, but the power modules that are down in here, there's a couple DC to DC power modules and AC to DC modules because it has to take grid energy and DC stored energy into the vehicle. Hold on one second. What's up? Thank you for the note, Alyssa. Appreciate that. Some of those power modules, I can't remember if they're the AC to DC or DC to DC, are from our sponsor, InfyPower. Yes. And so this is actually stress testing our sponsor here. So we're putting them on the spot to see if they can do all of this. So when we go to full charge our Lucid at those charge point stations in Wellington, it really stops at like 96%, 97%. They almost can't full charge the car because they just can't get the voltage high enough to actually get it to charge. So we will be bringing the Lucid here and charging it up to 100 and seeing if it can give it a full completed charge. Genuinely, I have no idea. On the other hand is the Equinox. The Equinox uses GM's 85 kilowatt hour roughly battery pack. It's actually a little bit bigger than that, but they say 85 kilowatt hours. And it's so low voltage. I'm talking low 200 volt range when it's completely dead, maybe like 230. I haven't actually tested it when it's actually dead. That's what we're going to find out here to see how the heck this thing does. It is the lowest voltage new vehicle on sale in America as far as I can tell. The only thing that will come close to this is the new electric Mini Countryman, because that uses the same battery pack as the iX1 and iX2. When I had that in Germany, I was so surprised how low voltage that was. So if you come in here, and we'll start with the low voltage one. I've got this thing at 0 miles of range. I don't think it'll even move. I'm gonna try and put it in gear just to see what happens. And right now it says reduced acceleration. It says out of energy, charge vehicle now. And I have the heat on high, and yes, it will not, yep, it won't drive. It's completely dead. They do this as well when you when you kill them, the screens go black when you hit the brakes, which is not like a very comforting feeling. But I've got it completely dead at the bottom of the pack. The contactors are open. The heat isn't even blowing hot anymore. It's out. And sometimes the screens, you have to cycle the door to get them to come on and off. Sometimes it takes them a minute, but that's just is what it is. With that said, should we do the first stress test? Let's see if we can actually charge the Equinox from dead. If we can't, I'll have to bring the Cybertruck or Lucid over and AC charge it. So we have options. And it's a Sunday, so no one's here that needs to charge. So we'll go in with our Amphenol cable here. It says it's plugged in. It knows it's plugged in. If you look here at the charger, I'm going to hit start. And let's see. By the way, the charger is still in free vend. I know some viewers have come by to check it out. That's awesome. Just try not to do it during office hours. That's my only request. But I will have access control on this soon. So if you come by and it doesn't work, that's probably why. We will, figure out a way for everyone who wants to use it to get a chance to use it though. So come on over, Alyssa. Let's look. 232 volts dead. And man, it did it just fine. The guys at XCharge were like, actually, I don't know. They were like, I don't know if we could get there and do that. But yes, it is DC charging the lowest voltage new car. So that's about as low as we'll get, 230 volts. I can't think of much that's going to go below 230 volts when it's completely out of juice. And again, it wouldn't go into gear. This thing was completely dead. You can see it's already up to 252 volts as we put some charging load on this thing. And this is the problem with the Equinox. This is not an Equinox review, but just selling such a low voltage car that needs 250 amps, it's only getting 63 kilowatts. I cannot for the life of me figure out what the rationale was other than cost savings and just the module placements of doing a low voltage car like this. I spoke to the lead engineer of Equinox about this issue and he was just like, yeah, well, it's just how the battery packs are laid out. I'm like, lay them out differently. Okay, so that is the situation. What I'm gonna do is probably charge this up to 5 or 10%, turn back off the CCS connection, let the high voltage battery pack, which is roughly 800 volts architecture in the XCharge unit, charge back up to 100%, and then we will stress test by charging the Silverado from 0 to 100%, and I think we've got it down pretty low, right, Alyssa? We're, 5% state of charge right now. So this thing's gonna sit here and do the ultimate, that's what I'm really curious to see. Can this thing handle deep charging the Silverado without issues? I don't know. We have been charging for just about 10, now 11 minutes, and you can see we're down to 57 kilowatts, and that's all that this cable can give it. It's a cable limitation. I would like to upgrade this cable to a higher amperage cable. We currently are running it, it's 200 amps nominal, but then 250 amp while in boost, and to me, it's just not enough power, especially for these low power cars. The charger can give it way more. I mean, we're only sitting at 200 amps. This charger can output, up to 180 kilowatts on a high voltage car. But that's the hard thing about branding high power or maximum charging capability of chargers that can't do 500 amps or more is, someone with a Equinox, as an example, may roll up to our charging station. And again, it's not really a public station, but this, just speaking generally, they may see max output 180 kilowatts and then plug in and see, 56, 57, 58 kilowatts while charging and go, what the heck? Is it a problem with my car or the charger? When in reality, the car is just so low voltage, still 289 volts at 12%, that we cannot give it the current it needs with this cable. Now, what's nice is my NAX cable is actually a 250 amp nominal boost to 300. Still 300 amps isn't a ton, but one thing I've asked the XCharge guys to do is to say, hey, can we open up the window that we operate in boost? It only does boost for a few minutes and everything's very cool to the touch. Like there's no reason why we couldn't run this cable harder. And they said, yes, we can put a more aggressive boost profile on there. And I'm like, yeah, let's send it. Give it the juice. I don't care if we burn up cables. I just want to give it the most amount of power possible. What I am worried about, of course, is frying the connection point here mostly. But again, the cars are rated for very, very high current. And I believe the Equinox even has a liquid cooled inlet port, if I'm not mistaken. At least the Cadillac Optic does. So anyway, pretty interesting. I would say we're going to stop the charging on this now. We've delivered 13 kilowatt hours to the car.
93% on the big battery pack. So what's happened during this charging session is I believe we've taken grid power, 30 kilowatts of it to the car, and then we've supplemented that extra power from the battery pack. So it's, just normal how you would expect this type of system to work. All was good, perfect charging session, no complaints. Let's hit stop. I just would like to upgrade this cable to higher amperage, which the charger totally supports. We choked it with these cables, but you can absolutely get higher power charging. So now we're juiced there. We're gonna let this, you can see it's already charging. You can see it says grid going into the battery pack. We'll let this charge up to 100%. While that's happening, we're gonna drain this to 0. And I'm actually gonna use the NACS connector with an adapter on the Silverado, just so it stays at higher current, at least 50 amps higher, and at high voltage for most of its charging session. So I'm gonna go back, I'm gonna turn off the CCS handle on this side. So let's turn this side off. That way no one can use it and drain the battery. Okay, I've got this awesome app here, web app for my XCharge station. And you can see, what am I trying to show you? Yeah, everything about fill, which is the name of this charger. And we can set a max limit on SOC of the car or the charging station or anything like that. But I'm actually going to disable connector P1. Boom. Got to click it. Are you going to recognize that I'm hitting you? Okay, what the heck? Let's reload the page. Oh, it did get it. What am I saying? And it says connector is not available. Simple as that. It just didn't do a nice gentle toggle. All right, let's show that one more time. So we have this one's not available. I'm going to click enabled on, and boom, instantly it's enabled. I'm then going to click again off. Boom. Wow. As soon as I hit this, that goes. But then this toggle takes a second to update. And there we go. Man, that's freaking awesome. Okay, I love having remote control. By the way, I can show you one of my favorite features here is if I go here to Energy, Microgrid Overview, this will tell me exactly what's going on with the charging station. So you can see I'm taking in 29 kilowatts to the battery pack. That's that battery. And that is currently at 760 volts. The interesting thing with the Lucid 2, and maybe even the Silverado, is it's going to start at lower voltage than the high voltage battery pack and then come across where it then has to match voltage and then boost voltage. So it's going to have to switch like a buck boost conversion midway through the charging session, as that's gaining voltage and this is losing voltage. And I'm really curious to see how it handles that. So anyway, let's go shuffle some cars around, drain that to 0, grab the NACS adapter, and then run this thing flat out. One thing, if you're going to be towing with the Silverado EV, Alyssa, what is your recommendation?
Don't go low.
Yeah, definitely below, I would say 7 or 8%. It doesn't give much. You're wide open throttle, right? Yep, to the floor, and it won't go above 42 miles an hour. 20 kilowatt output. Man, that just seems pretty brutal here at low states of charge. You can give it a hit of regen, it'll pull pack voltage up, and then a burst of power. But if you want to maintain speed, especially with a trailer, I wouldn't go below 10% really, just to be safe.
Maybe not even that, 15.
Yeah, I think 10% you're okay. I just think super down low, these things just cannot output the power.
It is now roughly 1 hour later, and I have drained the Silverado to where it won't move anymore. I got so lucky just pulling into the parking lot with enough energy to coast it and nose it into this charging. I couldn't back it in, but that's okay. The cable should reach even with nosing it in. That is because the port is on the back driver's side, like Cybertruck, like other Tesla vehicles, which is why we arranged it in this way, so Teslas could pull in here to use the NACS side. Again, the reason I'm using the NACS side of this charger is because this is a 300 amp cable. It's 250, 300 boost to 350 or 250 boost to 300? I think 250 boost to 300. And this is 50 amps lower. So I figured if we're going to really drain this thing, let's go with the highest power possible. So without delay, the Silverado literally won't turn on. It's dead. 12 volts alive enough to keep on charging. And what's going to be interesting is not only to see the total energy delivered to the truck, which is going to be well over 200 kilowatt hours, it's going to see if this can keep up. I'm curious if there will be any fault or weird dip as we cross over and under the voltage period, where, you know, this is going to be higher voltage than the truck when starting, and then it will be roles reversed through the middle of the charging session somewhere as that loses state of charge and this gains state of charge. And I talked to XCharge actually just a minute ago, and I was like, hey, I'm doing this thing. They're like, oh, it shouldn't be a problem. These things charge BYD buses all the time. I'm like, oh, if I can charge a bus, it should be able to charge this. And this is realistically the most energy capacity of any vehicle we would ever need to charge. Here for the foreseeable future. This is about the biggest battery, maybe RAM charger, but it's going to be in the same region as this. So let's get it plugged in. There we go. Nice and plugged in using the official NACS to CCS adapter. It knows it's plugged in. Let's hit start and let's see what the heck happens. So it's preparing. Can't wait. So I've also turned off this side. That's why that side says unavailable. I've shut this off so no other car can come and plug in. And hopefully no one messes up our test. Because I think once I left a car here and someone tried to unplug it or something. Don't know. We're still preparing. Come on, handshake time. Is the truck just so dead that it's not even going to charge? Might need to put a booster on the 12 volt. Let's try opening the door. No, the lights turn on the inside. The screens are basic on. It's thinking. Contactors just clicked. Yeah, it's working. Maybe it was so dead I needed to open the door to get it to actually communicate. We've got 10 seconds left before this thing faults out because it has a 60-second timer. Come on in here. I can hear a bunch of stuff clicking. This indication is showing the battery's charging the car. Come on, baby, let's go. Nope. I think it just didn't give it enough time because the truck had died there. So preparation failed. Anyway, let's try one last time. One last time. I mean, we got to charge this thing one way or another. So in we go. Thank you for hitting start there, Alyssa. The truck is now powered on, so it should happen much quicker. I'm hoping. Failed again. What the heck? The truck knows we're connected to it because it's locked the connector. There we go. Just released the connector. Okay, weird. Let's give it a second. Whoops, this is the wrong switch down here. Let's try and... This just beeped 3 times. Don't know why. Okay, it's not hitting the bollard. Okay, truck tried to turn on and then just died. So it might not have enough voltage to actually get the battery pack into a series configuration, because when they charge these, there's normally 400 volt. Roughly it's low 400 volt, like 3 something. And then when you plug into a high voltage charger, which this is, it'll have to wire the battery pack into a series configuration rather than parallel. And that requires energy. And if the 12 volt can't do enough energy to get the contactors to go, maybe not, but that would just be such a bug with Silverado if you couldn't charge them on a DC charger when they're dead. As far as I can tell, it's nothing on the charger side at the moment. It's just the truck. So we've plugged in. I know that the truck has power because the rearview mirror light is on. Let's try it. Things are clicking in the charger. Truck's waking up. Oh, look at this. The truck just woke up. It says charge cord connected. All the screens just lit up. It got like a little boost of energy there. Now will it charge? Hopefully so. Okay, I want to try this side of the charger, and weirdly I plugged it in, didn't even hit start on the charger, and this has gone red, but maybe it just thinks it needs to be authorized. Let's try it. Yeah, so I've activated the CCS side. So we tried like 3 or 4 attempts on the NACS and it wasn't working at all. And I'm thinking it's the truck. This will determine if it was the truck or the charger, if it works here for sure. So let's let it do its thing. Truck knows charge cord is connected. Similar behavior so far. I don't think it's going to charge. Now, the question is why? Is it the truck that won't go into high voltage? Or is it the charger? Or should I cycle the 12 volt on the truck? Maybe. I could try that first before we do anything. Just pull the 10 mil off the 12 volt. All right, let's do that because this isn't obviously going to work. I've got my Silverado toolkit handy. Always carry a 10 millimeter wrench with you whenever you're doing GM stuff. We're going to pull off the negative terminal. That should have killed the truck now. Let's see if you can see if you open the door. Does anything power up? Any lights on the interior?
No.
Like the overhead lights, you know?
No.
Should be dead, right? Okay, we'll give it a few seconds. We'll throw this on. That'll re-energize the truck.
And this is just so many times I've had to do this. I don't know if it's the problem or not, but it's always the first thing I go to try on General Motors EVs. I have now cycled the power on the truck, and it's actually showing 0% now, which is probably a better indication of actual battery status. Let's try plugging it in now and seeing if it works. Only 3 minutes in and the cooling fans just kicked on in here. There's some big fans to push air through the power modules. And they just kicked on, kicked off, but they'll power cycle as needed. And man, we've got the voltage up almost to 700 volts. This thing was on the ground. Holy smokes. So shout out to Chevy for sending us this truck so we could make the video for you guys stress testing our charger. Of course, we've done a lot of other things with it, but one of the benefits of having access to something with 200 plus kilowatt hours is to be able to do a stress test like this. Now, what's cool is you can already tell we've drained the battery pack down to 95%. Interesting. And that's this indication right here. That's our state of charge. And then if the bar is moving to the left, it means we're discharging. If it's moving to the right, it means it's charging up the big battery. But it's a really cool concept where we were able to replace a level 2 charging station, put in this battery integrated unit, charge this thing up, and then output 180 kilowatts of charging power, no problem. And as the voltage is coming up, this cable can handle a full 180 kilowatt charging session. That's awesome. We'll be able to look at the charging curve later on, but we're only 7 amps into our boost right now and still ripping at our maximum conversion power, which is 150 kilowatts output from the battery pack and then 30 kilowatts from the grid, making 180 maximum. You can see we've come out of our boost. We're down to 250 amps on the nose, which means our total power has come down a few kilowatts. I still don't like the way how the boost is done based on arbitrary time rather than temperature monitoring. That would be the way to do it, because the only reason to have a boost is to protect against overheating. But especially as we're coming into the winter months, I really think we can run these cables a bit harder. So, I mean, Tesla can do so much power on those little tiny supercharging cables. Yes, they're liquid cooled, but either way, you guys get the idea. I think we can do a boost for at least 10 minutes if we're going to set an arbitrary time. That's kind of industry standard. So with that said, let's let this thing boogie, and we're going to go do some other stuff. We'll come back here in, I don't know, a couple hours when it's done and fully charged. I am now arriving back to the charging station, this time in the Equinox, and oh, Silverado's almost done. It's at 97%. Let's go see how it's doing. Okay, well, I can tell it's getting windy out here, but I can tell the battery is really low inside the unit because that bar is small. So let's see. Oh man, it's so funny. They're completing right around the same time. So the battery pack in here is at 7%. And in the, oh my God, we've delivered over 216 kilowatt hours to this thing. It's at 98% according to the screen, and then 97 what it's communicating to the charger right there. Oh my goodness, that's a freaking charging session. Everything very cold to the touch. Nothing's warm. That's awesome. Damn. So basically one full charge took this thing down. Now, in terms of recharging it, it actually won't take that long. What I think I'll do just to show you guys is once this completes, I'm actually going to continue the stress test. I'm going to drain this all the way to 0. And then we're going to see roughly how long it takes to get up to 100% state of charge in this battery pack. So I have this one still at 20 something percent because I actually was AC charging it at my house. And yep, so we'll drain the big battery out of that to 0 just so you guys can see what happens, because it does actually derate power output a little bit as it gets down towards 0. The Silverado has just hit 100% state of charge indicated both on the screen and what it's telling the charger, still doing 35 kilowatts at 100%, absolute monster. But this means we shouldn't really be draining the big battery too much. It should be supplementing a bit from the grid. And interesting behavior here. This max output on the other side, definitely I can tell the battery is in derating on the unit, because this was saying well over 100 kilowatts just a minute ago. So we've delivered 221 kilowatt hours almost. It's almost at 800 volts right on the top. So a huge voltage spread from 530 when we plugged in up to 800. Absolutely massive spread of operating voltage. Takes 1 hour 40 minutes or so on this unit, and that's just because it's not a full big boy charger. This thing can only do 180 kilowatts, but man, did it sit pegged at 180 kilowatts for the full charging curve of the Silverado. That was awesome. So I'm going to let it complete up to 100%, make sure everything works perfectly fine. Then we're going to plug that one in and see what happens when this battery completely drains. Because to be honest, the first time I completely drained the big battery out of here, it all faulted. It was like, oh no, everything's bad. And then the second time that I did it, it just went to grid power and sat there, which is what it should do, which is say, okay, that's dead. Let's not charge that. We'll give the car everything it wants. And I can change all these settings on the back end, but I have it set in max mode. And then that will basically just give the grid power to the Equinox. So it turns my 180 kilowatt charger for high voltage cars or 70 kilowatt charger for low voltage cars into a 30 kilowatt charger from the grid connection. But that's all this thing's getting right now. So truck says it needs another 15 minutes. There we go. Charging just stopped. Heard everything click. We're down to 1 kilowatt. Boom, charging stopped. Now the question is, the grid will start charging the battery pack instantly. Not sure why I didn't do that during the low power charging session. With that said though, I'm going to plug in the Equinox right away just to show you guys what happens when this thing hits 000. Let's drain it. Okay, I have plugged in the Equinox. Let's hit start. You can see maximum output 75 kilowatts. So it's going to do some from the battery, about 35 kilowatts according to what it thinks is possible. So let's take a look at our charging performance now. Again, the Equinox can pull everything, and I'm using the NAX cable that can give it a bit more amperage, but we might be limited based off the battery pack. So let's let it rip. Charge cord connected. It's getting cold out there, 43 degrees. Holy smokes. Whoops, gotta wash the windshield too. It's got like little bus windshield wipers in here. And we are charging slowly, 8 kilowatts. Boom, ramping. We're at 288 volts at 23%. Are you kidding me? That is just crazy. There we go, 230 amps or so, doing 68 kilowatts. Now again, it can output more. This is a 300 amp cable in boost mode, but doesn't seem to want to give us any more than that at 2%. So it should go for a little while now at 2%. I've seen it take a really long time to drain all the way to where it takes grid power. But let's do it. Let's suck the juice out of this thing and we are, see how long it takes to go from 0 all the way down to nothing. Now, if we had a high voltage car, maybe it would take a little bit less time, but we're total power conversion limited right now. Not so much voltage limited. You can see here we're down to 1% on the battery at the moment, and we're still ripping 68 kilowatts, doing pretty well. This thing, I think, has a 1%, doesn't really mean totally 1%. There's quite a bit of usable buffer down low. So we're gonna let this thing rip until it goes all the way to 0, and I'll show you guys what happens. You can see here, we are still at 1%. We've been charging for 16 minutes. We put in like 18 kilowatt hours. So this thing will run at 1% for a disproportional amount of time. I think they really should mean, they got to adjust their like BMS display logic, because it's definitely still ripping 44 kilowatts plus some grid stuff, and we're taking in the juice. we're up to 42% on this thing. So you get a pretty meaningful charging session starting at like 2% on that thing, which is pretty funny, but I guess works. Okay, I logged into this little screen here. I like this one. It shows that there's 2.33 kilowatt hours remaining energy left in the battery pack. And today alone, we've charged 260 kilowatt hours of energy. That would have been the first charging session on this Equinox, plus the Silverado, plus the second charge on the Equinox. Also, an Uber driver with a Solterra came by to use the charger. He said it's his last day. He hates electric cars. It charges too slow. There's not enough charging infrastructure. I felt really bad. I was like, dude, that's a bad experience. Man, they really got to give you like a Model Y or something better to Uber with than a Solterra. So anyway, I'm doing an experiment on this, but he was dead. So I actually plugged him into my garage in the back of the powerhouse. But if I wasn't here, he would have just gone to EVgo, which is across the street. But I was like, he was really concerned about paying for charging, all these things. And I was just like, well, I'll just charge you up in the back of the unit or the back of the powerhouse. And hopefully he has a better EV experience one day. And I was like, just rent a Model Y next time. Don't rent a Solterra for Uber. Anyway, still at 2.33 kilowatt hours left in the battery pack. Shows SOC 1%. This is our energy transfer chart for the day. So you can see our first plug-in, that was this car. Then we sat ripping between those hours with the Silverado, derated a little bit down there towards the end. And now we're charging again. This is our SOC from the battery today. I had it charged to 80% last night. Normally I actually charge it to 90% every night. This morning before we did our tests, I juiced it up to 100. So I went in here and set the charge limit to 100. On the weekends, I set it to 80 just because it gets a lot less use on the weekends than during the week. Of course, no need to set it to 100. Bumped it to 100, did our little charging session, and then boom, one session just came right down to 0. Love it. So the question that you, I, and many others have had beyond just this stress testing is 230 kilowatt hours of battery storage enough? Or is a 30 kilowatt grid connection enough? Well, XCharge has the answer. You can actually purchase this unit with 2 battery packs, so you can get over 500 kilowatt hours, effectively close to 500 kilowatt hours usable of energy storage content. That's cool. Although I think there's only been one day that I can remember that we've actually drained the battery down to 0 in this thing. Most of the time we get it down to like 60%, 50, 40%, and then it charges up. And yeah, very rarely are we seeing like more use than needed or more use than available energy. So I'm pretty pleased with the current setup, and this thing gets used a lot. So stay tuned for a next video where I analyze all the data, who's using it, some customer testimonials, and then talk about, okay, let's get some access control on this thing and not run into that Uber situation where if it is going to be out here and the building is closed, people should have, I think, the ability to use it, and we're just going to charge them a small fee to do that. Something more than home charging, but probably less than public charging out there. And that will go into a service fund for cable replacements, other upgrades, or even other charging equipment needed to come to the site here. We also are installing an Autel level 2 charger right over here in front of the building, and that will be an 80 amp, 19.2 kilowatt AC charger, EVSC. Really looking forward to that. Dang, this is really amazing. It still is showing that it thinks there's 2 kilowatt hours left in this thing. So I think maybe the BMS was a little bit off. I don't know. But we've ripped 30 minutes of full power on this, whatever, you know, all we can give this thing. And we're still ripping. Wow, I might need to get another car over here. We're already up to 57%. Still boogieing. Boom, right there. This is now outputting 0 power. We finally hit 0% in the battery. I just have that single LED on indicating no power. You can see here, not even a charge status indication. Wow, 45 minutes of ripping. That is pretty impressive how much energy there was below 0. Now, of course, if I maybe had a faster high voltage car, we could charge a little bit faster, but really not much because we were limited down there anyway. So it just kind of at the very end and then went 0. So there we go. Now let's see what happens when we go 0 to 100% on the battery pack. It is 6:14 and 40 seconds. At 6:15, I'm going to hit the stop button, and then we can see at what time we complete at 100% state of charge. So let's go 55, 56, 57, 58, 59. Stop the charge. Okay, now the car has stopped charging, and we have instantly started our grid connection right there. So what I'm going to do is disable this side port so no one can charge and mess up our results. And we're going to do a 0 to 100% charging session on our 230 plus kilowatt hour battery pack attached to our XCharge NZS. Well, technically it is the XCharge NZS. Okay, I can show you guys how I can shut off this charger. I've gone into charger details and I'm going to go connector disabled, and then there we go. It's not available. As easy as that. Freaking awesome. Love all the data in here. And I have it set to go to 100% and max power of 30 kilowatts. So this is what's going in. We have 707 volts in the big battery pack at 0%. It's quite a high voltage system, this one right here. So it's doing 42 amps at 707 volts, 29 kilowatts. We'll let that thing boogie up to 100. Well, there's always going to be some losses during a charging session, of course, and it was just over 8 hours, about 8.5 hours is how long it took to go from 0 until we're completed at 100% running off grid power. However, very rarely is that ever happening. Very much what's happening from the usage I'm seeing on our charger is someone will unplug at like 8 or 9 a.m. You get like the morning crowd that arrives to the office. You get the like afternoon guests and appointments, maybe some of the people that come up from Denver. And then you'll get like, maybe a couple Uber drivers or whatever at the end of the day. And in between all of these sessions, the battery is able to kind of get back up there in between. And only one time have I seen us actually drain it all the way to 0. And I believe that was on one of the days I charged it to 80% maximum. So anyway, yeah, the battery pack is doing just fine because our average kilowatt hour dispensed is maybe like 20 to 30 kilowatt hours. Average, of course, we'll see some bigger sessions, a lot smaller sessions, but no one's really doing a 0 to full on a Silverado is what I've seen. And now it is time for the final challenge, the highest voltage vehicle currently on sale in our market, passenger car, the Lucid Air, but this is the Grand Touring with every module in here. This is the 118 or 116 kilowatt hour, I think 118 now, right? With the updated module in here. Anyway, we are going to charge this thing up to 100%. One thing I should note is it's a few days later after we did the Silverado test, and our NACS cable side wouldn't work. We just had a dude with a Model 3 here, and it wasn't charging at all. So an update coming on some of the servicing that we've had with the charger. I really should mention this is now the fourth major fault. I have to go back and tally that we've had with this charger that's required software updates and service techs to come out here. So I don't want to paint a picture that this has been 100% perfect. They've been incredibly responsive and great from a service side and have never given us an issue. And they, literally will fly someone out or have someone come over and update it. But yeah, we just had to turn someone away because I didn't have a CCS adapter on me and the NAC side would not activate at all. So anyway, with that said, the Lucid's at like 35% state of charge. We're going to juice this thing all the way up until it goes to full or whatever the charger can do. This is going to be a really tough test to see if the modules inside our XCharge can get up to what this car needs fully charged. But it all starts now by just plugging it in and getting it started. Let me get this going. I am plugged into the charger now and we are going to hit start, authorizing, preparing. The car shows red and it says authentication error, but perhaps now that I've activated the charger, it will work. The Lucid has had some interop issues with this charger. Depends on the different firmware versions we've been running. Yep, and it says preparation failed. Okay, bugginess here. So what I'm gonna do is actually hit start on the charger first, and now we'll get it plugged. Well, just called the CEO of XCharge to be like, do you know what's going on here? Why is the car not charging? And he's like, oh, let me call the software engineers. And so shout out Atish, shout out XCharge. I mean, they're really very communicative, instantly trying to help solve their problems. And one of the cool things about us having this charger is, of course, being able to charge and test so many different electric cars on this particular unit. But one thing is for sure, I'm not able to get the Lucid charging on whatever software version is on the charger right now. So they're going to fix it, update the charger, and then in an upcoming video, we'll full charge this one to 100. This is all part of the fun. Actually, some of the reason they let us borrow this charger and really have this charger here at the office is for all of the crazy interop testing and edge cases that we are trying to put this thing through. So it's a learning experience for everyone. So thanks so much for watching this video. We'll see you in another one again soon. Bye-bye.